Hi physics students! Let's take a look at one of these big long specific heat problems. They're really not hard, you just have to keep up with all the variables. Brass is an alloy made from copper and zinc. An alloy is a solution of metals, so they're mixed together. A 0.59 kilogram brass sample at 90 degrees Celsius is dropped into 2.8 kilograms of water at 5 degrees Celsius. If the equilibrium temperature is 6.8 degrees Celsius, what's the specific heat of brass? The key to doing these is keeping up with all those variables. So let's write them down and we'll put them in order. All right, so we've got the mass of the brass, and that is 0.59 kilograms. And matter of fact, I'm going to write brass up here just so I can keep these straight because that is where it gets confusing. Water. All right, I've got mass of water that's equal to 2.8 kilograms. Right? I've got a temperature, an initial temperature for the brass that's, and I'm going to make that a B. I think that's initial. 98 degrees Celsius. And then I've got an initial temperature for my water. So the temperature of my water initially is 5. And then the equilibrium temperature, that final temperature of both, is 6.8. Okay? Now the formula that we use to solve these says that all of our energy is accounted for. In other words, all of the energy in the heat energy in the water and the brass, they're just going to shift from one to the other, so therefore they're going to be equal to one another, and we get a formula that looks like this. Specific heat of water times mass of water times the change in temperature of water is equal to the negative of the specific heat of the brass times the mass of the brass times change in temperature of the brass. Let's put a little W over here. Now you'll notice that we don't have the specific heat of brass. That's what we're trying to find. And the specific heat of water isn't given to us, but we can look that up in a table. And the specific heat of water is 4,186 joules per kilogram degrees Celsius. All right. So now we've got all of our information, we've got our formula, but you'll notice that we need to do some rearranging of our formula. Let me switch colors here so that we can see it a little bit better. I'm going to divide the mass of the brass and the change in temperature of the brass, and I'm going to take that negative with me too. If I do that on one side, I have to also do that on the other side. All right, so that makes all this cancel, and that's going to cancel out, leaving me with the specific heat of brass. So here's my new formula. Specific heat of brass is equal to specific heat of water times the mass of the water times the change in temperature of the water, all divided by the negative of the mass of the brass times the change in temperature of the brass. Now here's where we got to keep them straight. We're going to plug in our numbers, but we're going to keep in mind that whenever we say the change in temperature right here, we're talking about final temperature minus initial temperature. So specific heat of water, I'm going to get that one right off the list. That's 4,186. I'm going to leave the units off just because it's hard to write all that here. The mass of the water is 2.80. See how that chart comes in handy? Now, change in temperature of the water is final temperature, which is going to be 6.8 for both of them. That's our equilibrium. Minus our initial, which is 5. All of that divided by negative and the mass of the brass is 0.59 times my change in temperature, that's 6.8 minus 98. All right, let's make those numbers a little more understandable. We're going to first do the top. Pull up my calculator here, and let's look at the top. We've got 4,000, clear all that off there. Come on, little calculator. Clear. Okay, 4,186 times 2.8 times, and I'm going to put this in parentheses so it doesn't get all mixed up, minus 5 equals 21,097. Okay, let's put that one down here. 21,097. All that divided by my next one. So let's do that one separately. So we've got 0.59 times parentheses 6.8 minus 98, negative 53.8. We'll call that negative 54. Okay, negative 54. You see how my negative's going to go away because negative times a negative? All right, now I can do my 21,097 divided by my negative 54, which is now a positive 54. So 21,097 divided by 54. And that gives us 390, what's that again? 390.68. Oh, we can call that 0.685. It looks like, look at our stuff. We've got two significant figures, so we really only can use two significant figures here. So we can call that 390. And it's a specific heat, so it's joules per kilogram times degrees Celsius. There's our answer. And if you look it up online, you'll find that that is what it is. Hope this helped. Keep practicing those physics problems. You always get better with practice. Bye.